Let's understand this problem diagrammatically. So here we have two planes. The first plane I have shown in black color, that is 4x minus 3y plus 2z equals 12. This is one plane. And there is another plane which I have shown in green color, that is x plus 5y minus z equals 7. And these two planes intersect, and when these two planes intersect, we see that there is a line formed. So this is basically the line of intersection. So we can determine the equation of this line, and then we have to determine the equation of the plane which I have shown in blue color. And this plane is perpendicular to the line of intersection. So basically we can consider that the line of intersection as a sort of a normal to this plane. So we have a point on the plane, that is 4 comma 3 comma minus 2, which lies on the plane, as well as a normal vector which is along the direction of the line of intersection. So once we have these two information, that is the point as well as a normal vector to the plane, we can find the equation of the plane. So our first task is to determine the equation of the line of intersection. That is, we have to find the equation of the line formed when these two planes intersect. So let's see how to find the line which is formed by the intersection of these two planes. To determine the equation of the line, I'm going to use the equation of the planes because the line is formed by the intersection of these two planes. So we have the first equation, that is the one of the plane is 4x minus 3y plus 2z, and this equals 12. And the other equation is x plus 5y minus z equals 7. So we have to solve these two equations of plane so that we get the equation of line. And the equation of line that we are going to form, we will form in parametric form. It is we will get in parametric form. So we can solve this by elimination method. I'm going to eliminate z, which means I can multiply this equation by 2 and add with the equation 1. So I'm going to write the first equation as it is. That is 4x minus 3y plus 2z. This equals 12. And down below that, I add the second equation by multiplying by 2. So I have to multiply each terms by 2. This becomes 2x. 5y times of 2 is 10y. And then negative z times of 2 is negative 2z. And this equals 7 times of 2 is 14. So now we can add these two equations so that the z will get cancelled or eliminated. You can see that positive 2z and negative 2z gets cancelled. Now 4x plus 2x is 6x, and negative 3y plus 10y is positive 7y, and this equals 12 plus 14 is 26. Now I'm going to solve for x in terms of y. So I keep the 6x as it is, and this equals 26 minus 7y. Now I divide both sides by 6, so I get x by itself. So this equals, I have to divide both terms by 6. This is 26 by 6 minus 7y divided by 6. Now I let y equal to t so that we can form the parametric equations of the line. And I'm going to substitute y equal to t into this x. So I get x equals 26 over 6 minus 70 over 6. Now let's substitute this x into the any one of the equation. I'm going to substitute in equation 2. It seems to be simple compared to the equation 1. So x equals 26 by 6 minus 70 over 6. We then have plus 5y. So plus 5, y is t. So I replace this as t minus z. This equals 7. Let me multiply all the terms by 6 so that the fraction is removed. So this implies we will have 26 minus 70 plus 5t times 6 is 30t. This negative 6 z. This equals 6 times of 7 is 42. Let's solve for z from this one. This is negative 70 plus 30t is positive 23t. So we have 26 plus 23t minus 6z equals 42. And we solve for 6z, that is negative 6z. This equals 42 minus 26, and this equals 16. So we have 16 minus 23t. Now I divide both sides by negative 6 so that we can solve for z. So therefore z equals 16 over negative 6 minus 23t over negative 6. And this equals z equals negative 16 over 6 plus 23 by 6 t. So we have now solved x, y, and z in terms of t. This is y equals t, and this is x equal to 26 by 6 minus 7t over 6. So now that we have the parametric equations of line, we can write down its direction vector by taking the coefficients of t of each of the components. That is, in x, we have negative 7 by 6. This is the coefficient of t. And in y, the coefficient of t is 1. And in z, the coefficient of t is 23 over 6. In fact, we can normalize this by multiplying by 6. So when you do that, we get negative 7, comma 6, comma 23. So this is the direction vector of the line. In fact, we can utilize this as a normal vector. So the normal vector is along this direction of this line. So we see that normal vector is negative 7, 6, comma 23. Now we can determine the equation of the plane, that is the required plane, using the point. The point is 4, 3, minus 2. So we consider the point, that is 4, 3, negative 2. We can utilize this formula, that is a times of x minus x1 plus b times of y minus y1 plus z times of, sorry, this is c times of z minus z1. This equals 0. So this is the equation of the required plane. This is basically a formula. We have to substitute the a, b, and c. The a, b, and c are the components of the normal vector, and x1, y1, z1 are the point. So this is x1, y1, and z1. So I'm going to substitute the a, b, and c as negative 7, 6, and 23. So when I do that, I get negative 7 times of x minus x1 is 4 plus b is 6. So 6 times of y minus y1 is 3 plus c is 23. So 23 times of z minus z1 is negative 2. So therefore this becomes negative of negative 2 will become positive 2. And this equals 0. Let's simplify this. So here we have to distribute, that is negative 7x, positive 28. And this is 6y minus 18 plus 23z plus 23 times of 2 is 46, and this equals 0. Let's put it in standard form, that is x, y, and z uh, coming first. So therefore I can write down this negative 7x plus 6y plus 23z. Then add the numbers, 28 negative 18 plus 46. 28 negative 18 is 10. 10 plus 46 is 56. So I put positive 56. This equals 0. In fact, we can rewrite this in a different form by multiplying by minus 1 so that we will have a positive term to the x component. So it is 7x minus 6y minus 23z minus 56 equals 0. So either could be the equation of plane, or this could also be considered as equation of plane.